A person stands next to machinery in an industrial manufacturing facility. Figure 10. One manufacturing involves a lot of data analysis, and Excel's data analytics supports corporations every day. Credit. Modification of Man Standing Beside Heavy Equipment by Katerina Babieva/Pexels, CC0. Chapter Outline. 10. Data tables and ranges. 10. More about formulas. 10. Using arithmetic, statistical, and logical functions. 10. Pivot tables. 10. Auditing formulas and fixing errors. 10. Advanced formatting techniques. WorldCorp's Fairfax, Virginia, location is a manufacturer of consumer electronics, and it regularly fulfills orders for its Portland, Maine location, where their products are shipped worldwide through the port. WorldCorp's sales are increasing, but the Fairfax plant is struggling to keep up with the orders. Their Fairfax location is more than 10 years old and no longer has the capacity they need. The corporate headquarters has approved an expansion of their facility. The regional manager wants to keep the original facility but increase the amount of square footage through adjacent additions. Executing this expansion will involve project planning, acquiring the needed materials, determining the needed funding, working with outside suppliers, and so forth. The data generated during the expansion will need to be evaluated and regularly tracked to ensure the project stays on time and within the budgeted resources. Microsoft Excel can facilitate this type of analysis to aid the decision makers as the projects progress. In this chapter, you will use the what-if scenarios of each location in the walkthroughs and exercises to rename cell ranges, use the autofill feature in tables, and practice simultaneous calculations of formulas. Excel also supports the associated statistical and financial analyses required for WorldCorp learning objectives. By the end of this section, you will be able to differentiate between a spreadsheet and a data table, explain the advantages of a data table, insert a data table from data in a spreadsheet, define a cell range, select and name a cell range, differentiate between a cell range and an array. WorldCorp has sufficient savings for capital investment for the Fairfax project. Yet the Chief Financial Officer, CFO, wants to borrow from a bank about 50% of the amount of the estimate for the new addition. There are many banks in Fairfax, each offering different interest rates and years to pay back the loan. The CFO is not sure which offer is best, as the longer the loan period is, the more interest WorldCorp will end up paying, yet the shorter the loan period, the higher the payment will be. The CFO is also analyzing the different interest rates and how they affect the installments and subsequently the total interest charge over the life of the loan. This case shows why it's important to learn the intricacies of using Microsoft Excel's data tables. Data tables can be helpful to assist management in determining the best course of action by evaluating interest charges and monthly payments. In this section, you will create a data table from existing data and will discover the advantages of using the data table tool in the what-if analysis, plus related concepts and definitions, such as data ranges and arrays. The data table's powerful analysis options will be further explored in organizing and presenting data, differentiating between a spreadsheet and a data table. Spreadsheets have a wide variety of applications and can be used for accounting, budgeting, data collection and analysis, and operations efficiency. Spreadsheets are used in all departments of corporations, such as marketing or operations. These departments can use spreadsheets in a variety of ways, such as compiling information from market studies or performing statistical analysis on operations from the manufacturing plant. A data table is a scenario-building tool. It lets users choose a set of cells on the spreadsheet and then outputs different solutions or forecasts depending on different scenarios. The difference between a data table and a spreadsheet is that a spreadsheet is a file with blank cells that can be formatted using the various tools and commands contained in the application. A data table can be part of embedded in a spreadsheet, but a spreadsheet can also include a graph, some text for information, or the listing of the inputs for the data table. The data table feature of Excel automatically builds a table of data based on certain inputs that is part of the spreadsheet. Figure 10.2 shows an example of an Excel-generated data table, as well as the data used in the scenarios. You will build a data table after learning more about its uses. Column B lists text data, column C lists numerical data, Cell C13 is selected, equals C10 shows in formula bar. Data table shows 5 columns and 6 rows of information in cells C13, G18. Figure 10. 2 data tables are added to a spreadsheet and are auto-generated in Excel based on the input you select. Used with permission from Microsoft. The advantages of a data table. The advantages of data tables are many. One of their most important advantages is their ability to automate scenario building. Another advantage is increased accuracy due to less manual entry of data. If you were to create a scenario from a blank workbook, you would need to build out the formulas initially and then copy them through the desired levels of the inputs. This increases the possibility of user error caused by inputting values or formulas incorrectly. By using the data table feature, all that work is done automatically and quickly. Data tables allow users to view all the levels of inputs in a single table without inputting multiple formulas. Consider the example of expanding Fairfax's World Corp location. You have gathered the needed information to determine the amount of the loan you will need to finance the added capacity. You have the loan terms from banks in the area, and you know that the loan payment period will be 10 years. World Corp is working on its annual budget, so the CFO wants you to investigate the annual payments, not the monthly payments. The CFO also wants to examine the variability of the annual installment if the interest rate is increased by 0.5% increments per year over the life of the loan. The data table in the what-if analysis will automatically perform the annual payment calculations for each increment. The CFO will then be able to look at the results and determine which loan from which bank will best meet the company's needs. The first step in this analysis is to set up your data. Since you're looking at how the interest rate affects the annual payment, you can use Excel's payment PMT function, which uses the present value, the value of the loan, the number of payments, and the rate. The PMT function is in the Financial Library of Functions found on the Formulas tab. The present value PV is principal to be borrowed. In this case, we will use $750,000, which is half of the total cost of the expansion. This was determined by the initial research by the CFO as the amount needed to finance the company growth. The time period of the loan has been set at 10 years. Most loans are paid monthly, but since you are analyzing the annual payments, you will use 10, not 120, for n shown as n per in the function builder to define the number of payments. After gathering all the interest rates offered by the banks, it was determined that the average interest rate I of all is 6.5%. Using these input values, the yearly payment can be determined using the financial PMT function. Figure 10.3 shows the building of the PMT function in Excel. Cell B4 is selected in the spreadsheet, equals PMT B2, B1, B3 is in the formula bar. Function arguments pane displays PMT. Rate B2 equals 0. 65, N per B1 equals 10, PV B3 equals 750,000, FV equals number and type equals number. Formula result equals minus 104,328. 5175. Figure 10. 3. Using the inputs of the interest rate, the number of years, and the principal amount, you can quickly determine the annual payment for the loan. Used with permission from Microsoft. The result is an annual payment on the loan of $104,328. $52. Figure 10.4. The output for Excel with the PMT function is negative by default, which is displayed in parentheses and in red. This is to indicate that the loan total will decrease by that amount each year after the payment is made. Keep this in mind as you examine the output. Cell B4 is selected in the spreadsheet and equals PMT B2, B1, B3 shows in the formula bar. The number 104,328. 52 in cell B4 is red font. Figure 10. For the PMT function in Excel calculates the payment required for a loan. The output is negative by default to show that the loan will decrease by that amount each time a payment is made. Used with permission from Microsoft. The next step in the analysis is to compare the payments with different loan terms. You can calculate the payment manually using the PMT function many times, that is, every time you change the interest rate. You can play around with it by changing the interest rate and seeing how it affects the payment. If the rate is lower, the payment will be lower, and if the rate is higher, the payment will be higher. For example, in Figure 10. 3. If you change the rate to 5%, the payment automatically updates to $97,128. $43. However, this approach does not retain all of the options easily. Unless you make a separate table to capture the impact of changes in the interest rate on the payment, that information is lost each time you make a change to the inputs. If you do create a table, you would need to format it in a manner suitable for additional analysis and decision-making. It would be a time-consuming exercise to record all of the data for each interest rate, and then you would need to take an extra step to summarize it in an easy-to-follow table. By creating a data table, you can use various levels of the interest rate to calculate the payment and summarize it in one concise table. Real-world application. Calculating mortgage payoff schedule. PMT is a useful tool for comparing different interest rates and their impact on monthly payment. It can also be used to determine a mortgage payoff schedule. Paying down a mortgage at a faster pace than agreed upon can lead to significant savings in interest payments. Even one additional payment a year can have a large impact on the amount of interest paid. You can find any number of amortization templates available online, either where you input the information and the site calculates it for you, or through an Excel template. Do some online research to find an Excel template to help you calculate your mortgage payoff schedule. Open the template and review the formulas. Notice the use of IF and PMT functions throughout. Using the template, locate a home to purchase and determine the payoff schedule for the home using today's interest rates. If you own a home already, determine what one additional payment per year will do to your final home cost upon payoff. Creating a data table from data and a spreadsheet. To facilitate the process of comparing various interest rates on the annual payment, you can create a data table. To do so, the information must be arranged on the spreadsheet in a specific way. First, make a list in a column of the interest rates being examined. The order doesn't matter to Excel, but it makes the data easier to analyze if you put them in numerical order, either lowest rate to highest or vice versa. In the next column to the right and one row above, use the PMT function to calculate the payment at the current rate. Recall you used 65%, as shown in Figure 10. 5. Cell F1 selected in spreadsheet and equals PMT B2, B1, B3 is in the formula bar. Column E shows percentages in 0. 5% increments and the number 104,328. 52 in cells B4 and F1 is in red font. Figure 10. 5. To create a data table, you must first determine the list of input values, in this case the changing interest rate. Used with permission from Microsoft. Next, select the area of the spreadsheet where the changing input values are contained. In this example, that is cells E1, F8. On the Data tab, you will see the What If Analysis menu group on the right side. Select the drop-down arrow and choose Data Table Figure 10.6. What If Analysis button is selected and opens to options for Scenario Manager, Goal Seek, Data Table selected. Figure 10.6. To create a data table, use the What If Analysis menu. Used with permission from Microsoft. When the Data Table tool is selected, a dialog box appears for inputting data. Because the interest rates are listed in columns, use the Column Input Cell box. In this cell, place the cell reference for the original interest rate used in the PMT function. Notice the $sign in front of the letter and number in the cell reference. This will set the column input cell to always refer to the value in cell B2. This is referred to as an absolute reference. You will learn more about absolute references in absolute cell references. For this example, the cell is B2, Figure 10.7. Columns E and F selected in spreadsheet. Column E displays percentages. Cell F1 displays $104,328. $52 in red. What If Analysis is selected and opens to options. Scenario Manager, Goal Seek, Data Table selected. Figure 10. 7. If you had placed the interest rates in a row rather than a column, you would use the Row Input Cell box instead of the Column Input Cell box. Used with permission from Microsoft. The data table will automatically calculate the payment at each of the interest rates listed in the column below the PMT, as shown in Figure 10. 8. You will need to format the data to be accounting or currency. Column E lists numbers as percentages in 0, 5% increments. Column F shows negative numbers with 3 or 4 decimal places to write. Cell A1 is selected with years N in formula bar. Figure 10. 8. When the data table is created, the output is not formatted. Use the accounting or currency format to display the data correctly. Used with permission from Microsoft. This process will save a lot of time, as it eliminates manually creating a formula for each cell. Furthermore, with the same data table, any of the values in the list can be changed, and the information will automatically update to the correct value. For example, to see the payments for a 6.4% interest rate instead of 6.5%, simply change that one value, and the row's value will be auto-filled to calculate the new installment payment. The rest of the data table stays the same, as you can see in Figure 10. 9. 2 columns of data are shown. The cell with 640% shows the number $103,840. 83 to its right. Figure 10. 9. Notice that by changing the cell to 6.4%, the payment changes only for that value, used with permission from Microsoft. Suppose you have taken this data table to the WorldCorp CFO, who tells you that the company will not pay high interest rates and will only negotiate and meet with the executives of banks that offer rates at or below 7%. There is no need to create a new data table that only includes the data for that range of rates, because you may need the information at a later point. Instead, you can temporarily hide the values that exceed the 7% maximum using Excel's filtering tools. A filter is a tool that lets you select certain criteria so that only data with your chosen criteria is shown. To use a filter within the data table, select the Rate column and then go to the Data tab. In the Sort and Filter command group, select Filter, the funnel icon. When Filter is selected, a small arrow will appear at the top of the column, as shown in Figure 10. 10a. Select that arrow and go to Number Filters, then select Less than or Equal to. On the dialog box that appears next, select 70% from the choices and then click OK. The result is that the data table will only show values that are less than or equal to 7%, as shown in Figure 10. 10b. A Number Filters is selected, opens to selection for less than or equal to. B. A table displays a funnel icon at top of the first column. Figure 10. 10a. In the drop-down menu, there are many different filter options. B. The funnel icon in a cell indicates that a filter has been applied to that column. Used with permission from Microsoft. Now that you have created a data table with one variable, you will follow a similar process to analyze two variables. With the added capacity in Fairfax, WorldCorp can sell more products to help the company reach its strategic goals. Increasing unit sales could also allow the company to reduce its price per unit. You would like to better understand the impact of the increased sales and price changes on the annual revenue for WorldCorp. Let's assume that in 2020, WorldCorp sold 5,000 RX 500 digital scales in the state of Virginia at the retail price of $17.99 per unit. That would mean an annual revenue of $89,950 for this item. What would happen if the price was decreased to $16.99 in hopes that the unit sales would increase? Or conversely, what would happen if the price increased to $18.99? WorldCorp is not sure how the public will react to either option, but you can estimate the revenue it will produce. Let's assume that either sales will stay the same, i.e., 5,000 per year, decrease to 3,000, or increase to 7,000. With the data table tool located in the what-if analysis, all the revenues will be auto-filled for the different unit sales and the different prices. Figure 10. 11. To create this table, follow the steps for the loan interest rate example. However, instead of only including the column input, also include the row input. In this spreadsheet, column A is filled with text data and columns B, D, E, F, and G are filled with numerical data. Figure 10. 11. In contrast to the previous example with loan interest rates, this data table uses two variables. Price row input and quantity sold column input, used with permission from Microsoft. Defining, selecting, and naming a cell range. A cell range is a selection of rows or columns of cells that is given a name to make it easier for the worksheet designer to find that specific group of cells later. It can include a group of cells that are next to each other or separated across the worksheet or workbook. Defining a cell range is especially useful when designing a large Excel worksheet with a substantial amount of data, or when interconnecting datasets or different spreadsheets. Naming a range of cells is referred to in Excel as defining a range. You can define a range in 3 different ways. Method 1. Define a range. First, select the range of cells you want to name. Then, click on the leftmost box below the ribbon. Excel calls this the name box. After the cursor on the name box begins blinking, type the name you want to use for the data range and press Enter. Subsequently, you may refer to this range of cells as the name you typed in the name box. Type digital scale in the name box, as shown in Figure 10.12. An arrow points to a box in the top left of the spreadsheet with digital scale inside the box. RX 500 shows in the formula bar. Column A is selected. Figure 10.12. The name box sits just below the ribbon and above the column letters, used with permission from Microsoft. Method 2. Define a range. Begin by selecting the desired range of cells, then go to the Formulas tab and select Define Name. A new dialog box will appear. It has 3 fields: name, scope, and comment. Next to name, simply type the name you want to use for the data range. Under scope, select Workbook. The comment field is optional. Click OK to complete the process. Figure 10.13. Columns A and B are selected in a spreadsheet. Define Name is selected. A new name pane lists name, price, scope, workbook, comments, blank, and refers to equals sheet 3, B$2, B$6. Figure 10.13. The Define Name option is in the center of the Formulas tab ribbon area, used with permission from Microsoft. Method 3. Define a range. The third way to define a range is more comprehensive, as it allows you to select various columns or a whole data table. You need to select the entire table or the set of columns or rows that you want to define. After making your selection, go to the Formulas tab in the ribbon and choose Create from Selection. A dialog box will appear and where you select the headers. Many tables have column headings only and other tables have row headings. In the dialog box, you will select if the table has the column headings on the bottom or on the top, or if the row headings are on the right or on the left. Using the World Corp example of the loan interest rates, choose left column and click OK, as shown in Figure 10.14. Because you didn't type anything, as this method is more geared for tables, Excel automatically gave defined names to the data ranges rows. Excel uses the text in the left column of the table to define the data ranges. Spaces are automatically converted to by Excel. Consequently, the data ranges are years N, rate, principal PV, and payment PMT. A. Create from Selection is selected and Create Names from Values in the left column is selected. B. Cell B1 has been renamed years N. Figure 10.14. A. To activate the Create from Selection command, click on the area shown after first selecting the data table. B. Notice that cell B1 has been renamed years N based on the title for that row listed in the left column, column A. Used with permission from Microsoft. Differentiating between a cell range and an array. An array is similar to a cell range in that it is a collection of data in ranges of cells, but arrays do not have to be contiguous, right next to each other. Arrays can contain text or numbers and can span multiple rows and columns if needed. The array can be a collection of cells that consists of unrelated elements, whereas cell ranges have a start and finish and are made of elements related to each other. Arrays also are different from data ranges in that they can work creatively to simultaneously calculate different computations at the same time. An array can replace many standard formulas and make simple computations more efficient. The array formula performs multiple calculations on several values, so using arrays and array formulas can save users time. Let's use the World Corp digital scale example and recalculate it using arrays. The unit sales of each model are added to the previous data in column C. Then, Using arrays, you can determine the total revenue without calculating the revenue for each model separately. Figure 10. 15a shows how you can add a column for the revenue of each model and then add them up to get the total revenue of the digital scales. Figure 10. 15b shows the total revenue for sales of all models in cell C7 without any of the individual calculations, using an array. To use an array to calculate the total revenue in Figure 10. 15b, click on a blank cell here, cell C7, and type the function equals sum b2, b6 asterisk c2. C6 and hold down Ctrl plus Shift as you press Enter. This function calculates the sum of the revenue for each item, as shown in the ranges in the parentheses. As visible in the formula bar, Excel recognizes B2, B6 from the defined data ranges and renames it price in the formula. Excel also adds a curly brace before and after the whole function Figure 10, 15b because it recognizes it as an array. Excel then does all of the calculations we did manually in Figure 10, 15a in one step and provides the total revenue. You'll notice that the total revenue values match, regardless of whether you do the calculations manually or use an array. When a selection is defined as an array, then any formula is calculated as an array formula, which allows for multiple calculations to happen simultaneously. A cell D2 displays equals B asterisk C2 in the formula bar, $89,950. $0 displays in cell B. Cell C7 displays equals sum price asterisk C2. C6 in the formula bar. In the cell, the number $614,870 is listed. Figure 10. 15. The array formula enables Excel to derive the same results using less space in the sheet. A. You can calculate each model's revenue and then add those values to get the total revenue. B. You can also use an array which determines each model's revenue and adds them up in one step. Used with permission from Microsoft. Learning objectives. By the end of this section, you will be able to create complex formulas, use cell references in formulas, use comparison operators, use arrays in formulas. Portland is a small city in Cumberland County, Maine, and is Maine's most populous city. Its main commercial attraction is that it is a port city, and among the main economic activity in the region is marine transport services. WorldCorp has an office there, as the company uses the port facilities to export some of their products to different destinations. The WorldCorp regional manager has to use intricate spreadsheets to keep track of the large volume of cargo coming from different cities in the United States. The manager wants to start using data automation intelligence tools in Excel, allowing the manager to make operational decisions more quickly. The shipping information may contain data such as the origin city, the destination, types of inventory included in the cargo, the weight of each shipment, and specific international shipping terms for the shipment. The manager receives this information separately in each bill of lading, a summary of the shipment, and has constructed many complex Excel workbooks with different tabs, each containing the raw data from the cargo. With shipments increasing year by year, this raw data has grown and become unwieldy. Using Excel's built-in analytical tools, such as cell references, comparison operators, and array formulas, the manager can make sense of this raw data to use and process it in a more helpful way. As a WorldCorp employee, you are asked to deliver recurring reports based on this data. These reports can be tedious to create if you are not able to immediately find the information you need in your spreadsheets. In this case, you are asked to find the heaviest shipment, the average tonnage, the most used destination, and other report highlights. Excel's analytical tools like cell references, comparison operators such as greater than, and array formulas allow all the information in your spreadsheet to be summarized automatically. Using comparison operators enables powerful functions that are used for different purposes when constructing array formulas. Cell reference notations, relative, absolute, and mixed, are used to construct automated tables. A relative cell reference means that the cell used in the formula will change if it is copied to another part of the spreadsheet. More specifically, both the column and row location are not fixed. An absolute cell reference occurs when both the row and the column are fixed to that exact cell. So if you copy the formula to another location in the spreadsheet, it will always reference the same cell. A mixed cell reference is when either the column or the row is fixed. If the column is fixed, the row will be relative when copied to another location in the spreadsheet, and if the row is fixed, the column will be relative. Understanding cell reference notations will help you learn to build and use complex formulas using the correct order of operations. More advanced use of cell references will allow you to use comparison operators and arrays in different situations. Complex formulas. As calculations grow in complexity, they require the use of several operators such as plus, slash, asterisk, and in the same formula. This is the basic definition of a complex formula, a formula that uses several operators to calculate an output. One important aspect of complex formulas is that Excel will automatically calculate them in a specific order. When first working with complex formulas, it can be helpful to write out the formula on paper first. To input formulas into Excel, use parentheses to separate the different mathematical functions. Multiple parentheses might be needed when working with complex and long formulas. For example, to add cells A1 and B1 and then divide by cell C1, it would look like letter 1D4341 plus letter 1D4351. Letter 1D4361. If you wrote out the formula. In Excel, the formula is one single line, A1 plus B1 slash C1. Another strategy when dealing with complex formulas is to break down the formula into parts. To break down the previous example, you would do the addition part of the equation in one cell, and then in the next cell, do the division. Excel employs a color-coding system in complex formulas to help you follow the math, as shown in Figure 10. 16. Cell D7 displays equals E2 plus E3 plus E4 in the formula box. Cell D7 displays the formula and E2 is highlighted blue, E3 red, E4 purple. The corresponding cells are highlighted the same colors. Figure 10. 16. The color coding system for complex formulas is also applied when using multiple sets of parentheses in a formula. Used with permission from Microsoft. Insert function tool. Recall, the formula bar is located right above the lettered columns, right beneath the ribbon. The formula bar can be used for double-checking that what you typed in the cell was what you intended, or for editing the relative cell references of a copied cell. However, there is another feature in the formula bar using the insert function tool, which is essentially an assistant to help users build formulas. It contains the whole roster of Excel functions, categorized by discipline, e.g. engineering, financial, math and trigonometry, statistical, so users can explore and search for functions. Insert function is activated by clicking on the letter 192X icon that you see in the formula bar or by going to the Formulas tab and selecting Insert function. The function library command group on the Formulas tab also shows formulas grouped by category. Mac tip. In the Mac version, the formula bar only shows the most commonly used formulas, but you can expand the Formulas tab. Let's examine how to use the Insert function tool for a simple function, the sum function. Note that the Insert function tool is typically used for more complex and specialized functions because it is quick and easy to just type in the simple formulas. However, here the sum function provides a simple example. First, select the cell where you want the summed total to appear, then click on the Insert function icon. The dialog box will open, asking for the function you want to use. Select the Math and Trig category and look for sum. They are listed alphabetically. When selected, a second screen will appear and ask for the range on which to perform the addition. Select the range and then click OK. Mac tip. In the Mac version, the formula builder defaults to the last formula you used. One useful feature of the Insert function tool is that it can automatically detect what your range might be. Figure 10. 17a. In Figure 10, 17b, Excel automatically guessed that the user would want to sum the range F2, F5. This Insert function tool is useful when you do not want to manually type the formula in the formula bar. A. Insert function is selected. B. Column F is highlighted in spreadsheet. Function arguments pane selected number 1 F2, F5 for sum and the formula result equals $7,539,906. 10. Figure 10. 17. The insert function tool includes tips on how to apply each function. Used with permission from Microsoft. Order of operations. In all math equations, there are rules regarding the order in which calculations must be completed. Otherwise, the equation result will be incorrect. The order of operations is the universal law of math used to prescribe the order of doing each calculation in an equation. Parentheses, exponents, multiplication, division, addition, and subtraction. Going from left to right, the acronym PEMDAS can help you remember the order. For example, if you calculate 5 plus 3 asterisk 3 5 from left to right, you would add 5 and 3 to get 8, then multiply 8 by 3 to get 24, and then subtract 5 to get 19, which is incorrect. Following the mathematical order of operations, the equation should be done in this order. Multiply 3 by 3 to get 9, then add 5 to get 14, then subtract 5 to get 9. You can also use parentheses to help show the correct order of operations, such as 5 plus 3 asterisk 3 5. The parentheses show that the multiplication should be done first. Excel requires equations to follow the correct order of operations, using parentheses when combining operations in a single cell. Let's look at some WorldCorp revenue streams to see this on a larger scale. WorldCorp produces thousands of different consumer electronic products, including TVs. Figure 10:18 shows the number of TVs sold for each of these models in the volume sold column. To calculate the margin for each model, subtract the cost from the price. Then, to calculate the profit per each model marginal profit, multiply the margin by the volume sold. A spreadsheet provides the following columns of information: model, price, cost, margin, volume sold, and marginal profit. The last row provides a total for the marginal profit column. Figure 10:18. Several simple formulas were used to calculate the profit margin for each model. Used with permission from Microsoft. To calculate the total profit margin, you can use the sum function on the marginal profit column. This simply adds up all of the profit margin amounts for each model. Alternatively, you can get this same total by creating a complex formula. Subtract the cost from the price, then multiply the difference by the volume sold, then add the product of each model and the quantity. Remember to use parentheses to make sure that each section of the formula is completed in the right order. The formula would look something like this: equals price 1 cost 1 asterisk volume sold 1 plus price 2 cost 2 asterisk volume sold 2 plus price 3 cost 3 asterisk volume sold 3, etc. The calculation in figure 10:19a shows the wrong answer that would result from not using parentheses in the formula. It uses the formula equals price 1 cost 1 asterisk volume sold 1 plus price 2 cost 2 asterisk volume sold 2 plus price 3 cost 3 asterisk volume sold 3, etc. Which means the cost is multiplied by the volume sold first before being subtracted from the price, which is not correct. Figure 10:19b shows the formula written the correct way with the parentheses. It uses equals B4C4 asterisk D4 plus B5C5 asterisk D5 plus B6C6 asterisk D6 plus B7C7 asterisk D7, which gives the correct result. A. Cell D8 is selected and formula bar displays equals B4C4 asterisk D4 plus B5C5 asterisk D5 plus B6C6 asterisk D6 plus B7C7 asterisk D7. $6,582,923. $90 displays in the cell. B. Cell D8 is selected. Formula bar displays equals B4C4 asterisk D4 plus B5C5 asterisk D5 plus B6C6 asterisk D6 plus B7C7 asterisk D7. $7,539,906. $10 is inside cell D8. Figure 10:19 in A, the volume sold is incorrect because the parentheses that determine the order of operations in the formula are missing. B is correct. These formulas show how easy it is to make a mistake in the order of operations. Used with permission from Microsoft. Cell references in formulas. In defining, selecting, and naming a cell range, you learned about cell references and how to define a range of cells. Now we will expand this into Excel's cell reference notation and learn how to use relative, absolute, and mixed cell references. Relative cell references. Formulas use relative cell references by default in Excel. A relative cell reference is one in which the cell reference in a formula or function updates automatically to reference an adjacent cell when you copy that formula or function to another cell. In other words, if your formula refers to cells A2 and B2, Excel knows that this means the columns are next to one another and in the same row. If you copy a formula with these values to the next row, Excel will automatically change the cell references to A3 and B3. Let's consider an example. You want to replicate the TV profit calculation equals B4C4 asterisk D4 plus, B5C5 asterisk D5 plus, B6C6 asterisk D6 plus, B7C7 asterisk D7 in another table with different models of TVs. You simply need to copy Ctrl+C the cell with the formula in it D8 and paste Ctrl+V it into a new cell D15, as shown in Figure 10. 20A, all of the price, cost, and volume sold values in the new table are different, and cell D15 is blank. Once you copy the formula into cell D15, as in Figure 10. 20B, the result is that the formula will be exactly the same, but the cell references will automatically be changed to reflect the new table. Equals B11C11 asterisk D11 plus, B12C12 asterisk D12 plus, B13C13 asterisk D13 plus, B14C14 asterisk D14. As a word of caution, this only works if the tables are uniform and the formulas needed are the same. A cell D8 is selected. Formula bar displays equals B4C4 asterisk D4 plus, B5C5 asterisk D5 plus, B6C6 asterisk D6 plus, B7C7 asterisk D7. Cell D8 displays $7,539,906. 10. Cell D15 is blank. B cell D15 is selected. Formula bar displays equals B11C11 asterisk D11 plus, B12C12 asterisk D12 plus, B13C13 asterisk D13 plus, B14C14 asterisk D14. Cell D15 shows $6,507,235. Figure 10. 20 Because the tables are identical in size and column values, the formula from A, the first table, will work perfectly when copied to B, the second table. Used with permission from Microsoft. Backtib. As a reminder, all shortcuts that use Control on a PC use Command on a Mac. Yet, as easy as relative cell references can be, they might not be appropriate for all circumstances. For example, you may have a set of informational data that will be used recurrently, but you don't want Excel to move the reference of one or more cells, so the relative cell reference function will not work. This is when a different type of cell reference can be used: absolute cell references. An absolute cell reference is one in which the cell reference is fixed, regardless of where you copy the formula. To use the absolute cell reference feature, put a before the column and row reference. For example, $A3 means that the reference to column A, row 3 is fixed. If you don't add both symbols, the absolute cell reference won't work, and you will simply have a relative cell reference. Another way to use the absolute cell reference is with a shortcut. Click on the cell you would like to fix and then click F4, and Excel will automatically add to the cell. Recall the loan you were analyzing for WorldCorp, but instead of using a data table what-if analysis, you will use the PMT function and absolute cell references. As shown in Figure 10, 21A, the same loan interest rate data remains, but now you will calculate the payments using absolute references. The formula in cell F3 equals PMT E3$C$2$C$400. You can click on the fill handle the lower right corner of the cell of cell F3 and drag it to F9. This copies the formula so that all the PMTs will automatically be calculated for you, using the fixed references to cells C2 and C4. Figure 10. 21B shows the completed table, and the formula in cell F9 shows the updated formula with absolute cell references. A cell C5 is selected. Formula bar displays equals PMT C3 C2 C40, $104,328. $52 shows in the cell. In Part B, cell F9 is selected. Formula bar displays equals PMTE9 $C$2 $C$400 $111,772. $12 is in the cell. Figure 10. 21. Using absolute cell references allows you to copy the formula to other cells without having to update your formula. A. The PMT formula in cell C5 calculates it using relative cell references. B. Using the absolute cell references for cells C2 and C4, you can create a table that shows the payment for various interest rates. Used with permission from Microsoft. Let's examine this formula without absolute cell references. In other words, using relative cell references. If cell F3 is equals PMT E3, C2, C400, and you drag the fill handle to cell F9, then all the values from F4 to F9 will be incorrect. Figure 10. 22. Essentially, you have copied the same formula, but the relative cell references have moved location along with the location of the formula. Instead of referring to cells C2 and C4 for each iteration of the formula, the reference moved down one row for each row you copied the formula down the table. Sum and name box. Formula bar displays equals PMT E9 C8 C10 00. Cell E9 blue, C8 red, C10 purple, C8 red empty, C10 purple empty, E9 blue. 80%, F9 selected formula inside, F7 and F8 NUM, green triangles in corners. Figure 10. 22. Using absolute cell references will avoid errors in your formulas when you are using the same cell in each of your formulas. Used with permission from Microsoft. Real-world application. Excel horror stories. Even the employee with the most certifications and skills in Excel can make mistakes. Excel facilitates most computations, but if the user makes an error in the formula or with entering the data, there can be significant consequences. For instance, you might think copying and pasting information would reduce errors. However, that was not the case for an employee working at J.P. Morgan Chase. In 2012, an employee copied and pasted content and formulas from one spreadsheet to another while working on a value risk model. The data and formulas were untested and unverified, and errors were carried over into the model. You should also consider the veracity and completeness of files you might receive. Barclays ended up purchasing 179 contracts they did not want from the Lehman Brothers in 2008. Why? They received a spreadsheet of Lehman's assets in PDF form. When they reviewed the Excel spreadsheet, they identified 179 contracts they did not want to purchase and hid those rows. But those notes were omitted from the PDF when it was converted, and the hidden rows were visible. Excel is a very powerful tool. With that power comes the potential for grave mistakes that can be incredibly costly. The utmost care and integrity must be taken to ensure fidelity of any spreadsheet generated and/or shared. Mixed cell references. A mixed cell reference uses a combination of both relative and absolute cell references. A mixed cell reference might have a fixed row but a relative column, or a fixed column but a relative row. When the is directly to the left of the row number only, e.g. $1, the row is absolute and the column is relative. When the is directly to the left of the column only, e.g. B1, the column is absolute and the row is relative. Let's look at another example. The World Corp Portland, Maine location offers different promotional discounts as a percentage of the TV retail price depending on the month. The manager asks you to create an auto-filled table of the unit prices per TV model for the year 2020. That is easy to achieve manually, multiplying the monthly discount times the retail price, but each cell reference has to be fixed as they move. To automate the calculation, you can use mixed cell references. Figure 10. 23 shows the retail prices per unit and the monthly discount rates. Column B lists TV model information starting in row 8. Column C lists months and shipping price information. Columns D to O list months and percentages for profits. Formula bar displays equals C9 asterisk 1D $4, figure 10. 23. Calculating outputs from tables with two sets of variables can be a good use of mixed cell references. Used with permission from Microsoft. In figure 10. 24. The discounted retail price for model 32 LCD hash E900s is $168, $30 to be calculated in cell D9. This is obtained by multiplying the price in column C9 by one discount rate found in cell D5. For this example, this would be 170 * 1-0. 1 or C9 * 1D5. Without absolute cell references for either the column or row, the table will not calculate correctly when the formula is copied. See Figure 1023. Placing the before the column C, for the price will fix the formula to always calculate the output based on column C, and the table will fill properly with the discounted prices when you copy the formula from D9 into the remaining cells. 2. Table visible. Upper table lists monetary values for discounts in columns R to X. Lower table is blank except for cell R12, selected with $168, $30 entered. Figure 10. 24. By having the columns fixed, the formula always references the price column. Used with permission from Microsoft. Comparison operators. The Excel comparison operators are the same as the inequality symbols used in math. These are less than, greater or equal to, or greater than or equal to, less or equal to, or less or equal less than or equal to, equal to, and not equal to. Comparison operators can be used for comparing numbers. Comparison operators are valuable because of their use in the if functions. With the if function or similar functions like sumif, countif, etc. Comparison operators can automatically search for important information. More will be covered about these functions in logical functions. Arrays in formulas. Array formulas can save time when used for basic or intermediate calculations. Recall saving the time of adding an extra column in Figure 10. 15. But more importantly, array formulas are used for higher-level calculations that may involve statistical and financial analysis, such as figuring out maximums and minimums of a certain product, similar to MINIF and MAXIF functions, or summing certain X or Y rows columns, similar to SUMIF. In short, most array applications can be done in other ways in Excel, but using arrays allows you to do multiple calculations at the same time. Let's use a manufacturing example to see how to use arrays in formulas. WorldCorp's Fairfax, Virginia manufacturing plant transports their items by truck to the Portland, Maine location. The Fairfax plant has plenty of stock for some of the items in the orders, but not for all of them. Figure 10.25 shows the available stock in the Fairfax plant, quantity in stock, and the amounts needed to complete the orders quantity planned. Let's calculate the difference between these two numbers to determine if more is needed. Specifically, if the quantity in stock column E is larger than the quantity planned column D, we will not need to manufacture more. To make this simple, we will use a simple subtraction calculation. Quantity in stock, quantity planned. If this value is a positive number, there is plenty in stock. This would be the case with row 6, tablet 7 in. The quantity in stock is 425 and the quantity planned is 143. So 425, 143 equals 282. So there will be 282 units remaining after filling the quantity planned order. If the value of the subtraction formula is negative, then more product is needed. We see this in row 4 where the quantity in stock is 464, but 542 are planned. Using the equation 464, 542, we are left with a shortfall of 78 units. Or, first, determine the difference between the values in column E and column D using an array. This will allow us to do the calculations for all rows in one step. Highlight cells G4 to G12. Then, in the formula bar, type the formula E4, E12, D4, 12 Figure 10. 25A and then press Ctrl plus Shift plus Enter simultaneously for the curly braces to appear, as shown in Figure 10. 25B. The formula then is automatically entered for all highlighted rows. A formula bar displays equals E4, E12, D4, D12 in blue column E and red column D. Cell G4 displays D4, D12. B formula bar displays equals E4. E12, D4, D12. Column G displays positive negative numbers. Figure 10.25 Make sure to highlight all the cells you want the formula to be entered into. A. Notice the color coding of the formula that corresponds to the colors in the columns below. B. If you don't press the Ctrl plus Shift plus Enter combination, the array will not work. You will see the curly braces when you have a formula as an array, used with permission from Microsoft. Link to learning. For those who are new to using the Excel math syntax and notation, the first section of this video tutorial on using math in Excel has a series of handwritten math exercises set alongside the same calculations using Excel. Seeing math equations written out in the traditional way may help you better understand how to devise Excel formulas. You can access the companion handout to use as a reference. Learning objectives. By the end of this section, you will be able to use basic financial functions, identify and use arithmetic and statistical functions, insert logical functions. The world has changed rapidly in the decades since the 1980s, as personal computers became commonplace in offices and homes. Business calculations that used to be done by people in highly specialized accounting departments using manual methods became automated. Production plans and managerial oversight are informed with data from ever-expanding datasets that include data from sales to manufacturing. To manage this data, WorldCorp uses complex worksheets that may link to other worksheets or other workbooks, with the aim of producing actionable business intelligence. To generate policies and strategic decisions, managers must use every tool at their disposal, including functions like min, max, STDV, financial calculations like PV, FV, PMT, and logical functions like IF, and OR, arithmetic and statistical functions. Functions used in basic math or arithmetic functions help users to add, multiply, find averages, and perform other types of mathematical operations. You have already learned how to use basic math functions, but there are others that will be very useful in basic data analysis, such as financial functions and statistical functions. Average. The average, or mean, is a number found by adding up a group of values, and then dividing it by the number of values you added up. Simply select the cell where you want to calculate the mean and type equals average, range, and identify the range of the values you want to average. Spotlight on ethics. The problem of using averages of averages. When reporting on data, it may be tempting to average a series of averages to summarize information or determine if there is a mass effect. It is especially tempting to do this in Excel, as it makes this process quick and easy. However, averaging averages is very problematic and can indicate a greater impact than actually realized. It is much better to use the original numbers to determine the actual average versus attempting to average averages. That said, what happens if you do not have the original numbers? This may happen if you are handed processed analysis separated from the original data source. In this case, using weighted averages is a better approach. Weighted averages take into consideration the varying levels of importance of different numbers that can be found within a given dataset. To ensure you capture the percent or proportion of importance of these numbers, each number within the dataset is multiplied by a predetermined value before the average is found. To underscore, it is best to avoid averaging averages and instead use original values to calculate the average of the totality of these values. If these are not available, you must use weighted averages that will factor in the number of values included in the averages to determine the correct average. You can do your own research regarding how to perform this calculation. There are plenty of simple but effective tutorials available online. Count rows and columns. The function count is useful when you have a large data set of rows or columns and want to know how many there are. When you type equals count, range, Excel will count the rows or columns with numerical values in the range you identify. The major drawback of the count function is that it will only count the number of rows columns that have numerical values, and it will ignore any text values. In this scenario, you need to use the rows or columns function to count all of the rows columns. Write them in the same way, equals rows range or equals columns range. Knowing the number of rows of invoices, for instance, can be useful if you need to have the exact number of n for an equation, max and min. Excel has functions that can determine the highest or lowest numbers in a dataset. Max equals max range finds the highest value, and min equals min range finds the lowest value. Figure 10.26. The range is the set of all of the cells you are analyzing to find the maximum or minimum value. Cell B13 is selected and equals min. F2, F10 is in the formula box. Cell A12 is labeled max with $64,505 in cell B12. Cell A13 is labeled min with $7,252 in cell B13. Figure 10.26. The max and min functions are useful if the dataset is very large and you cannot see the minimum or maximum value with a quick glance. Used with permission from Microsoft. Standard deviation. A common statistical tool used by many data analysts to calculate the variability of the figures in a dataset from the arithmetic mean is called standard deviation. In other words, it tells how much the figures vary from the average. For example, if you have a dataset of invoices from client A and the bills vary in their total by a considerable amount, then you would have a high standard deviation. If the invoices of client B vary less, meaning their totals are similar every time, then the standard deviation will be low. Excel has a quick way to calculate this, the stdev function. Type equals stdev range, and Excel will give the standard deviation for that range. For example, figure 10.27 shows the standard deviation for the range F3, F11. Two tables labeled client A and client B, cell I4 selected. Formula box displays equals stdev F3, F11. In cell I4 $1, $23.53 is shown as the standard deviation, cells H4 and H5 merged. Figure 10.27. The standard deviation is probably the most used statistical tool in the data analysis set of formulas. Used with permission from Microsoft. Financial functions. The main functions used for calculating loan installments, investment returns, net present value of capital investments, mortgage payment comparisons, and many more real-world applications are called basic financial functions. These functions are NPER, rate, PV, PMT, and FV, which correspond to the N, I, PV, PMT, and FV in financial calculators. You learned about the PMT function in the advantages of a data table. Date and time functions. On their own, the date and time functions do not seem very useful, as you can easily just enter a date or a time in a cell by typing them. But these functions are often used in conjunction with other Excel features, such as in array formulas or complex if functions. To enter a date, write equals date, year, month, day, using the date's numerical values, and Excel will return with a formatted date, such as 3/31/2021. For the time function, write equals time, hour, minute, second in 24-hour format, and Excel returns a time in AM/PM format. If you typed equals time 14:44/24, Excel would return 2:44 p.m. Logical functions. Typically, logical functions are long formulas with embedded logical tests and often use comparison operators to search for delimited data. They compare two values in your worksheet and return one result if the comparison is true and a different result if the comparison is false. These logical functions are powerful tools for allocating and sourcing large amounts of data. The if function is one of the most used functions in Excel. It is regularly used in conjunction with other functions. Moreover, if functions are regularly combined with array formulas. Figure 10.28 shows an example from the WorldCorp Portland, Maine shipments. The if formula, written as equals if logical test, value if true, value if false, analyzes the fob values and inserts over 20K if they are greater than or equal to $20,000. Cell G2 is selected. Formula bar displays equals if F2 greater or equal 20,000 over 20K. Cells in row G list over 20K in cells G2, G5, G6, G8, and G9 with numbers in column F showing above 20,000. Figure 10.28 Excel gives users the freedom to invent their own true and false tags. Used with permission from Microsoft. SUMIF and COUNTIF are other logical functions that are very useful. The SUMIF formula, written as equals SUMIF, Range, criteria, sum range will give a total of a given range, sum range, if certain criteria are met. For example, you can create a SUMIF function to search for and add up the amounts of all purchase orders of more than 30 servers equals SUMIF C3. C235, 30, D3, D235. The COUNTIF equals COUNTIF range criteria function is similar except that it gives you the number of cells that meet the criteria rather than a total. You can use a COUNTIF formula to find the number of invoices that are equal to a certain sale amount equals COUNTIF, A2, A500 equals 5,000. Using these formulas with comparison operators makes gathering intelligence from large datasets easy. Let's revisit our WorldCorp example. WorldCorp exports that go through Portland, Maine, use container ships to transport goods to their destination. Figure 10.29 shows the shipment data from March 2021. Apply COUNTIF and SUMIF formulas to gather information on how many shipments meet certain criteria. The Excel notation used for the COUNTIF formula in cell I7 is equals COUNTIF D2, D10, greater or equal 1000, which calculates how many shipments column D, quantity, contained more than 1000 pieces. The SUMIF formula in cell I2 is equals SUMIF F2, F10, greater or equal 20,000, which adds up all of the FOB amounts that were more than $20,000. Notice how the comparison operators and their numbers are in quotation marks. This is necessary to calculate the formula correctly. Row 6 selected. Cells H2 and H3 list all FOBs over 20K summation. Cell I3 displays $156,295. Cells H6 and H7 list shipments with more than 1,000 PCS. Cell I7 displays 2, figure 10. 29 different types of if formulas are often used to look up values that meet a certain criterion, used with permission from Microsoft. The AND, written as equals, and logical 1, logical 2, is regularly used in combination with the IF function. It can be used in limits, establishing a low and a high limit, and labeling them if they meet these criteria. In our WorldCorp example, this could help sales managers at the Fairfax, Virginia, location identify any invoices that are below a certain value, thus flagging those customers who might be retail consumers instead of wholesale. The formula in cell G2 in figure 1030 sets up an if test. If both of the AND criteria are true, if the FOB is greater than $0 and less than $1,000, then the tag low value appears in column G. Cell G3 is selected and equals if and F3 greater or equals 0, F3 1000, low value, is in the formula box. Low value is listed in cells G3, G7, G8, and G9 with adjoining numbers in column F under 1000. Figure 10.30 The AND function can be used as an interval as shown here, used with permission from Microsoft. The OR is similar to the AND function in that it compares two values, but with the OR function, only one argument needs to be satisfied. It too is often used in conjunction with the IF function. In figure 1031, the sales manager is automating the Excel worksheet to show when quantities fall outside of certain values. This could flag a product if sales fall below 200 units, for example, because it could indicate that it requires more marketing or additional investigation into the drop in sales. Likewise, the sales manager wants to know when quantities are above 1,000 units, which might trigger a discount for customers or additional incentives for the sales agent. Use the OR function to flag these orders for additional review. In the spreadsheet, cell F2 is selected with equals if or D2 200 D2 1000, yes, in the formula box. In column F, cells F2, F3, and F5 through F9 list yes. Figure 10.31 The OR function is more flexible than the AND function as the interval can be either. Used with permission from Microsoft. The NOT can also be used to look for values that meet a certain criterion. It is regularly used in combination with the AND, OR, and IF functions. In figure 10.32, NOT negates the criteria set forth by the AND function, namely that if the FOB amount is not greater than or equal to $0 and also less than $1,000, then the tag high value should appear in column G. Cell G3 is selected with equals if not, and F3 greater or equals 0, F3 1000, high value, in the formula box. In column G, cells G4, G5, G6, G10, and G11 list high value with adjoining numbers in column F over 1000. Figure 10.32. The not function is regularly used in complicated if functions, used with permission from Microsoft. Link to learning. Nesting occurs when we have a formula that uses a function and includes a function as one of the arguments. These functions are typically known as nested functions. Nested functions are used in the workplace to evaluate several conditions at a time. This can be helpful when you have multiple criteria that influence a single outcome. This can be a powerful approach to performing calculations in Excel. However, they can be very complicated as they require a specific structure in order to ensure accuracy. This tutorial from Microsoft walks us through this structure. The uses for this approach are limitless as you can nest up to 64 levels. Learning objectives. By the end of this section, you will be able to define a pivot table, organize and clean your data prior to designing a pivot table, insert a pivot table, understand and use the recommended pivot table tool, add a pivot chart to pictorially present the data. Pivot tables help data analysts use raw data and organize it into an interactive tool for summarizing and analyzing the data points. WorldCorp can, for example, gather their manufacturing data sets of each machine's daily performance and put this information into a table that the pivot table tool can use to analyze the information. This type of organization would be useful for producing various metrics, such as machine performance and company key performance indicators, KPIs. The pivot table tool can also divide data into a set of criteria, which will organize your data by variables you choose. This separation and division of data help you create business intelligence with ease. Definition and uses. Excel has various ways to store data and various tools that aid in data intelligence queries. You've learned the purpose of using what, if data tables, naming ranges, using comparison operators, and writing statistical and logical functions, all of which can be combined with arrays or other tools to make interactive and automated tables. Excel has an even quicker way to make relational tables and automated business intelligence. Pivot tables. A pivot table lets users create interactive charts and tables from raw datasets. They can process large, raw datasets and allow the user to choose how the data will be tabulated and summarized using easy drag-and-drop features. Pivot tables also help summarize the data for a professional appearance and to show it in a more user-friendly way. Out of thousands of rows and columns of raw data, you can produce a simple, easy-to-read table with different options for displaying your metrics. Some applications of pivot tables might include producing metrics for website views and ad clicks, displaying demographic information for a county or city, or gathering information about small business revenue. In each of these cases, pivot tables can be used to process large, ever-growing datasets into readable tables, organizing and cleaning your data. Let's return to the example of shipped products from WorldCorp's Portland, Maine location. Pivot tables can be used to aggregate values and create an actionable market analysis and business intelligence for the company. The first step of creating this pivot table is to organize and summarize the data. Having a digestible raw data sheet that Excel can read well enough to aggregate the data is critical. To clean the data, you should ensure that there are no merged cells anywhere in the data. All filters are inactive. There are no sum functions on the bottom or sides of the worksheets. All erroneous, duplicate, and/or blank values are deleted from the data. All values in each column are of the same value, e.g. currency, date, text. Next, convert your data into a top-down table, meaning that all of the data range headers should run along the top row of the sheet. This is the typical format for tables and will make using pivot tables much easier. In general, horizontal tables can be hard to follow. Cross-tabular source data with headers on top, bottom, and left-right are even more difficult to read for the pivot table generator. Designate a unique name for each top header. Do not repeat any column header names. Figure 10.33 shows a correctly formatted worksheet. You can copy this worksheet into Excel, or you can use the data in the Pivot Table Data tab of the downloadable Chapter 10 Data File Workbook. A large spreadsheet with columns and rows of data, both text and numerical. All of the unique data range headers run along the top row of the sheet. Figure 10.33. This small representation of data is a sample of what could be hundreds, thousands, or millions of individual shipments a month. Used with permission from Microsoft. Inserting a pivot table and rearranging variables. To create a pivot table, go to the Insert tab, choose the pivot table icon located on the far left, select the entire dataset, and output to new worksheet. Alternatively, you may name your data ranges as instructed in defining, selecting, and naming a cell range, and simply select the named ranges for your data. The field list will activate and ask which columns to display as shown in Figure 10.34. Select the headers variables in the order that you want the pivot table to display them. In the World Corp example, to see the quantity each client is buying, select destination, then quantity, and then FOB. As shown in Figure 10.35, the pivot table neatly displays the data, with interactive features allowing the user to select different pieces of information as variables. Pivot table field sidebar displays options for choose fields to add to report. Cell A3 is highlighted and a pivot table pane reads, to build a report, choose fields from the pivot table field list. Figure 10.34. The pivot table wizard can help to create clean, interactive tables from raw data. Used with permission from Microsoft. Drop-down arrow located at right of first cell in row 3 titled Row Labels. To the right in dialog box, the quantity, FOB, and destination boxes are checked in dialog box. Figure 10.35. The pivot table displays the data. Used with permission from Microsoft. Now, to further delimit the details of the clients, add date to the variables. Figure 10.36a. Because you chose destination first, you are separating all the variables and ordering them by client to know what the client is consuming in volume and in dollar amount. Adding the date allows you to see total sales but also breaks down the data by month. This is only one way to create a pivot table with this data. If you were to change the order in which you selected the headers in the pivot table wizard, the whole table would be different. Additionally, you can choose a different set of data to display, which changes how the information is grouped. To demonstrate this, uncheck date, you have to uncheck months too and instead check product. As seen in Figure 10.36b, the table gives a totally different perspective. Instead of seeing the data grouped by date, the grouping has changed to show the products the client ordered and the quantity of each. A. Pivot table displays information by location, then months. B. Pivot table displays information by location, then product. Figure 10.36. Selecting headers in a different order will change where and how they appear in a pivot table. A. The original table broke the data down by date, and B. The new table breaks down the data by product. Used with permission from Microsoft. You can easily change the arrangement of the pivot table using the fields in the lower half of the field list. You can drag and drop the variables from one field to another to change how they appear in the pivot table. For example, you can change the arrangement of the rows by putting product first. This automatically changes the pivot table completely from being destination-oriented as seen in Figure 10.37a to being product-oriented. Figure 10.37b. A. Drag fields between areas below. Pane displays options. Filters, columns, values, rows, destination product, value, sum of quant, sum of FOB dollar. B. Product, quantity, FOB dollar, destination selected for fields to add to report. Figure 10.37. Changing the headers can change the entire table. A. You can rearrange the data so that product comes first. B. The pivot table looks completely different from the previous destination-oriented table. Used with permission from Microsoft. Let's apply a filter to the results from Figure 10.37b. To filter by date, first check the date and month variables on the top half of the field list. Then drag and drop the dates from the rows to the filter field, as shown in Figure 10.38a. This will allow you to apply a filter to the dates and be able to select only certain dates. To see just the February sales, go to the month drop-down menu on the pivot table and select Feb. Now only the sales from that month will appear. Figure 10.38b. A. Months is selected in Filters in Pivot Table Fields sidebar. B. Pivot table displays information for the month of February in table. Figure 10. 38 filters are useful for when you want to see only a subset of your data. A. You can choose a single month in the filters. B. The table then shows you only that month's data, used with permission from Microsoft. Using the recommended pivot table tool. If you are unsure how to organize a pivot table for your data, Excel can recommend one depending on how the data is organized. Let's see what using a recommended pivot table might look like. Go to the Insert tab and select the Recommended Pivot Tables icon. A dialog box appears with a handful of recommended charts. Scroll and select the one you like best. These recommended tables may be helpful to get you started, but they only compare one variable at a time. However, if you choose one, the new pivot table will appear in another worksheet, and you can customize it there, adding or reorganizing variables until you have a pivot table that presents your data in a way that makes sense. Adding a pivot chart to visually present data. Excel has a feature that allows you to create a pivot chart to visually present the data in your pivot table. The first step is to select the entire pivot table, which causes the ribbon tab Pivot Table Analyze to appear. Next, select the pivot chart icon. You will use a small dataset from Figure 10:31 to create a chart of the information. More in-depth coverage of pivot tables is in Pivot Tables Charts. Figure 10:39 shows the original data and Figure 10:40 shows the data summarized in a pivot table by sales agent. To create a chart of the data summarized in the pivot table, choose Pivot Chart from the Pivot Table Analyze tab. Cell A1 is selected in a spreadsheet with date in the formula bar. Figure 10:39 the data is summarized in a simple table, used with permission from Microsoft. Pivot Chart is selected from Tools Command Group of Pivot Table Analyze tab. Agent and FOB dollar options selected to add to report in Pivot Table Fields sidebar. Table displays information for agents and corresponding FOB dollar. Figure 10:40 placing the data in a pivot table enables further analysis and filtering of the data to meet specific needs. Used with permission from Microsoft. For the data in Figure 10:40, a bar chart, pie chart, or clustered column chart would be optimal. These chart types are appropriate because they allow you to see the difference in scale between the sales levels of the agents. For this example, choose the column chart. With the column chart, the higher the column, the greater the sales totals for that agent. You can further customize the column chart by adding percentages or labels. The Agent drop-down menu in Figure 10:41 allows you to further filter or change the column chart. A bar chart is inserted into the spreadsheet reflecting information in Pivot Table at left. A drop-down rectangle in the lower left labeled Agent with a drop-down arrow at the right is visible. Figure 10:41 you can further customize the pivot chart by adding features such as value labels or by sorting the information in a different order. Used with permission from Microsoft. Real-world application. Using pivot tables to track spending. Pivot tables can be a powerful tool for businesses in budgeting and creating other financial reports and analyses. You can also use pivot tables for your own personal budgeting. There are many budgeting services available online or through apps, but you can create your own powerful budgets that can help track all personal finance matters, including spending, without paying for an online service or app. As an individual, you might be able to track your budget fairly easily. However, as your financial matters become more complex, or as your family grows, Excel can come in handy to assist you in managing your budgets without the additional expense of a service or application. To get started, you can download a CSV file of your transactions from your financial accounts. Most institutions will have this function where you review your account and transaction information online. You will want to collect all information, particularly from your spending accounts such as credit cards. Once these are gathered, be sure to validate the information, then create a column heading named Category. You will then create your categories such as food or entertainment. Some credit cards will auto-populate these categories when you download your transactions, but you will want to verify these are accurate. From there, you will complete your pivot tables using the instructions you can find in this textbook. You can opt to create different timelines of your budget, such as daily, monthly, or yearly, depending on your own budget analysis needs. Learning objectives. By the end of this section, you will be able to explain the reasons formulas may need to be audited, identify the various errors that may be present in worksheets and tables, identify the cells involved in a formula, implement the appropriate options for auditing various aspects of formulas. WorldCorp receives many client orders every day, and the corporation needs to have an accurate count of inventory to ensure that they have the capacity to deliver orders on time. This real-time inventory handling and customer relationship management can only happen by implementing computer systems that track these business activities. Microsoft Excel can be programmed to help in fulfilling these tasks with the right data. Yet, as you can imagine, this enormous data load can be daunting, and occasionally small errors may be made in some formulas. Excel has various tools for the user to identify such errors and thus correct them. Reasons to audit formulas. As a business grows, its activities grow in complexity, requiring higher level and concurrent data analyses. As a result, managers build large Excel workbooks to handle these business operations, designing spreadsheets with a wide selection of formulas, functions, pivot tables, arrays, data ranges, what-if data tables, and other Excel data exploration tools. Each of these tools requires user input, which makes them inevitably subject to user error. The process of using Excel tools to monitor and fix errors in worksheets is called auditing formulas. Remember that almost all formulas or functions have relationships to other areas of the workbook. Cell references or named ranges may even refer to other cell references, creating a complex web of references. If the key data points do not have the right formula or function, the resulting value will not be correct. You may also see an error message in Excel if the user settings are set to alert the user when a formula or function has a broken link or incorrect syntax. Identifying errors in worksheets and tables. There are many ways to check for errors in your workbook. These include tracing precedent functions, tracing dependent functions, showing the formula, and automated checking of errors. When tracing precedent or dependent functions, you are finding the relationships between cells. When you are tracing precedent functions, you are finding the source of an error in a formula by locating the cells that provide the data to perform the calculation in the active cell. The arrows will point to the cells that are used to construct the formula used in the active cell, so you may review them before making a correction. When you are tracing dependent functions, you are finding any cells affected by the active cell. You would want to do this before deleting a cell from a worksheet. These specifically relate to checking cell references and the information found within them. Figure 10.42 shows the output when tracing precedents for a cell. Cell J4 is selected with equals maxifs, $E$2, E$10, B$2, B$10 Antonio in the formula bar. The cell contains $26,016. Two arrows start from cells B2 Antonio and E2 $10,582 and come together to point to cell J4, figure 10.42. The arrows point to cells B2 and E2 that are used to determine the highest value in the formula, used with permission from Microsoft. Showing the formula is simply looking at a certain formula or function and manually checking its syntax. There is a command on the Formulas tab called Show Formulas that will automatically show which cells contain formulas. The actual formula in the cell is displayed, replacing the value that was calculated from that formula. It changes the content of the worksheet to show exactly what formulas are in the cells. This is a good first step to finding errors in formulas. To hide the formulas and return to the original spreadsheet with the computed values, simply select the Show Formulas command again. There is also an error checking command, which can help to identify specific errors in formulas. Before any error checking can occur, first make sure that your version of Excel is tracking the errors when they happen. Click on the File tab and select Options. In the dialog box, choose the Formulas tab and check the Enable Background Error Checking option. You should also check all of the Error Checking Rules boxes and then click OK, as shown in Figure 10.43. Formulas is selected in Excel Options window. Error Checking Rules options are visible and checked. Figure 10.43. Error checking starts with having Excel notify you if any error happens. Used with permission from Microsoft. Remember that there are two main characteristics that all formulas have: All formulas must start with the equals sign equals. Formulas have constants, cell references, or both, and operators, functions, or both. Constants are numbers that are typed inside a formula. They can be integers or rational numbers. Operators are math notation signs for performing different calculations, such as plus, asterisk, slash, and these operators must respect the order of operations PEMDAS. If the formula is complex, if it has multiple functions, for example, you must ensure that the function's syntax rules are obeyed. For example, the PV function must include values for rate, NPER, PMT, and FV in that order, or the function will not work. There are several types of potential errors. You may have syntax errors, not having the right argument in the function or having too few or too many arguments. Capacity errors. In Excel, you cannot have more than 64 functions in a cell. Or sheet or cell reference errors. It is worth noting that, when linking a formula in one worksheet to a cell in another worksheet, Excel automatically adds the sheet's name and after the sheet's name. You must double-check that you didn't delete this mark. For example, WorldCorp's data for 2 clients is seen in Figure 10.44a. You summarize the overall total on a separate sheet which references the first sheet. Notice in the formula the after the worksheet named data and before the cell reference you include in the calculation Figure 10.44b. A spreadsheet displays 2 tabs along the bottom. B summary tab is selected at the bottom of the spreadsheet. Cell B2 is selected and equals data. F data G2 displays in the formula bar, Figure 10.44a. You can use the data on one worksheet in a formula on another worksheet. B Excel will include the name of the worksheet followed by in the formula. Used with permission from Microsoft. Additionally, several errors have specific code assignations that should automatically appear in your cell if you have an error. These code errors are preceded by to indicate that they are errors. Some of the common code errors are described in Table 10.5 hash code explanation how to fix it. Hash this common error is a formatting error rather than a formula error. It occurs when the column is not wide enough for the numbers to be displayed. Make the column wider. Name. This error is displayed if the function is not well written, such as if there is a typo in the name of the function or the designated function name is not complete or is written incorrectly. Find the correct wording of the function by clicking on the Insert Function tool. Div 0. This error happens when you divide by 0. This can also be caused if a linked cell reference has no value. Enter a value in the cell or add the correct constant in the denominator. Null. This happens when the Excel notation syntax rules are not obeyed, such as if an operator is incorrect or missing. Follow the pop-up menu that appears when writing a function. It tells where commas should be, what value should be referenced, and so on. If the error was made in the past, you can consult the roster of functions on the Formulas tab in the ribbon and selecting the Insert Function icon. NUM. This happens when a cell reference contains contradictory or unsound numbers that stop the function from calculating the result. Check the reference cells and retype the numbers that are unsound. Ref. This means that the cell references in a formula are not there anymore, or the cell reference was entered incorrectly in the formula. Find the correct cell reference and fix the formula. Value. This happens when a cell reference has a different data type. For example, when you use a function that requires 2 numerical values but you insert text for one of them. Use the same data types. This happens when a function searches for a certain value and the function cannot find it. Change the criterion on the search operators, e.g. lookup function. Getting data. This is a temporary error. While waiting for Excel to calculate a complicated query, Excel will process the answer in a few seconds and display this error. Wait for Excel to calculate the answer. Table 10.5 common code errors. These are many of the most common code errors and how to fix them. Identifying the cells involved in a formula. Excel makes it easy to find cells that meet certain criteria. For example, Excel can highlight all cells in a worksheet that contain formulas. To do this, select a cell, Figure 10.45, and go to the Find and Select icon on the Home tab, then choose Go to Special Figure 10.46a. Next, select Formulas, then click OK, Figure 10.46b. All the cells that contain formulas will be selected highlighted in that worksheet. Excel also has a built-in feature called the Watch window that allows users to see where each constant, reference, and operators are correct. Select the Watch window icon on the Formulas tab in the ribbon. The Watch window will be blank, so choose Add Watch and select the cell or cells you want to analyze, as shown in Figure 10.47. Putting a cell or a range in the Watch window allows you to monitor the cells you choose to ensure they remain error-free as you continue to work in a worksheet. You can add multiple cells to the Watch window by following the same process. The Watch window tells you the value and the function, the sheet, the workbook, the cell, and the defined name to help you identify any errors. Cell F3 selected $97,128. $43 and formula bar reads equals PMT E3 $C $2 C $400. Find and select button options. Find, replace, go to special, formulas, notes, conditional formatting, constants, data validation, select objects, selection pane. Figure 10.45. The Watch window can tell you the relationships of the cell to other cells. You can use Find and Select to highlight cells that contain items such as notes or formulas. Used with permission from Microsoft. A. Formulas, numbers, text, logicals, errors selected in Go to Special pane. B. Select the cells that you would like to watch value of, equals name of worksheet. F$3 displays in Add Watch pane. Figure 10.46. A. Use Go to Special to define what elements you want Excel to search for in the cells on the worksheet. B. Watch window is an alternative to see the formulas in cells on a worksheet. Used with permission from Microsoft. The Watch window is shown with a row of headers and a row of data below in parentheses. Book operati, sheet cell name cell F3, value $97,128, $43, and formula equals PMT E3 C $2. Figure 10.47. Click Add Watch to list the cells and the formulas. Used with permission from Microsoft. Another way to dissect a formula is by selecting the cell and choosing Evaluate Formula on the Formulas tab. This command solves the formula piece by piece to ensure that the formula is built correctly. First, the formula displays as shown in Figure 10.48. Then, select Evaluate, which will solve the first argument of the function, then click on Evaluate again and the second argument gets resolved. Continue to click Evaluate to solve the formula one argument at a time until you reach the last argument, where the final step is the calculation result. This lets you confirm that the cell is calculating correctly. Figure 10.48 shows the Evaluate window when it first opens, and Figure 10.49 shows the last step before the final answer is shown in the window. If clicking the Evaluate button does not provide clarity on the formula, you can use Step In, which shows a more detailed view of all of the components of the formula. You are essentially going into the formula to see all the cell references that contribute to the data in that cell. If you use Step In, you will need to click Step Out to go back to the macro view of the formula and to proceed to the next argument, as shown in Figure 10.50. You can use this method to break down complex formulas that might include cell references in other worksheets. Evaluate Formula tool displays reference, cell reference ABS, F$3 equals evaluation. PMT E3 $C $2 C $400. To show the result of the underlined expression, click Evaluate. The most recent result appears italicized. Reads below, Evaluate button selected. Figure 10.48. The Evaluate Formula tool can easily show where the error is by solving for each argument. Choose Evaluate to go step by step through the formula. Used with permission from Microsoft. The Evaluate Formula tool is shown. PMT 0. 510.75000000 is listed in the evaluation window and the Evaluate button is selected. Figure 10.49. To see the result, choose Evaluate. Used with permission from Microsoft. Evaluate Formula tool displays reference, cell reference ABS, F$3 equals evaluation. PMT E3 C $2 C $400, then cell reference ABS, C$4 equals $750,000. Across the bottom reads, the cell currently being evaluated contains a constant. Step out button selected. Figure 10. 50 step in takes you into the formula for a more detailed view, and step out goes back to the original full formula instead of the individual components. Used with permission from Microsoft. Another way to see the references of a formula is by simply selecting the cell in question, and then pressing Control and open bracket to see dependent references, or Control and close bracket to see precedence. This simple method selects all the cell references of the formula in question, as shown in Figure 10. 51a. You can see that cells C2, C4, and E3 are selected and shaded in. These commands serve a similar function as the trace dependence and trace precedence tools. They show the dependent cells or precedence, but they do not draw a line like the trace dependence and trace precedence tools do. If a cell has no dependent cells that are depending on this data from other worksheets or workbooks, or from another table in the same worksheet, then you cannot perform the Control+ command, as shown in Figure 10. 51b. In this example, there were no dependent cells. A. Cell E3 selected 50%, column C selected. B. Column F selected, and formula bar displays equals PMT E3 $C $2 C $400. $97,128. $43 inside cell F3. Microsoft Excel window displays no cells were found. Figure 10. 51. The Control+ command is a simple way to see dependent cells. A. Excel highlights the dependent cells. B. If there are no dependent cells, Excel will let you know that there are none. Used with permission from Microsoft. The most comprehensive way to see your cell relationships is by installing the Inquire add-in. First, go to the Add-ins menu, File Options, Add-ins, Figure 10. 52. Look for Manage drop-down at the bottom of the window and select COM Add-ins from the drop-down menu, then select Go. Then check Inquire and click OK as shown in Figure 10. 53a. Excel adds a new tab to the ribbon. From that ribbon tab, select Workbook Analysis, Figure 10. 53b. The workbook will be displayed with all its formulas and connections between cells, and all formulas will be categorized by the type of function used, Figure 10. 54. This new ribbon tab also offers the features Workbook Relationship, Worksheet Relationship, and Cell Relationship, all of which give a graph of the relationship between the sheet and the precedence and dependence in the worksheet. Add-ins is selected in Excel Options window. Add-ins are highlighted in Add-ins pane with information listed beneath. Figure 10. 52. Access Excel options from the File tab to find add-ins. Used with permission from Microsoft. A. COM Add-ins window displays selection pane for add-ins available. Acrobat PDF Maker Office COM Add-in and Inquire are selected. B. Workbook Analysis is selected from the Report command group. Figure 10. 53a. Inquire is a formula auditing tool that does what the Watch window does, but also gives the found errors and organizes the formulas by categories. B. Inquire will be added as a tab giving you several options to choose from. Used with permission from Microsoft. A pane displays options for items, lists summary, workbook, formulas along with other options. Results, lists item, sheet name, cell address, formula, and export, includes item detail limit and Excel export button. Figure 10. 54. You will be able to see all formulas in the spreadsheet with their location identified by the cell reference. Used with permission from Microsoft. Mac tip. In the Mac version, all add-ins are located in the Tools menu. Choosing and implementing formula auditing options. Let's look at an example to practice identifying errors and choosing and implementing the correct ways to fix those errors. Using the World Corp loan installment example, suppose that the loan the company settled on has a 5% interest rate, resulting in a payment of $99,500. 83 per year in interest and principal. Therefore, the total cost of the increase in capacity for the manufacturing plant will be $995,008. $27. Cell F4 now has precedence and dependence, as shown in the arrows in Figure 10. 55. Cell F4 selected and equals PMTE4 $C$2 $C$400 in the formula bar. Cell F4 shows $99,500, $83, $3 arrows from cells C2, 10, C4, $750,000 0, and cell C12, $995,008. 27 all meet and point to cell F4. Figure 10. 55 the cell pulls data from many other cells. By using trace precedence and dependence, we can visually see the cells that are connected by formulas. Used with permission from Microsoft. The data in Figure 10. 55 looks good, but suppose you get a NUM error in cell F4 Figure 10. 56. Recall that this type of error means that the formula contains contradictory or unsound numbers that stop the formula from calculating the correct result. First, try the error checking tool. Change the location of the n variable to a blank cell, C1. This gives the error shown in the figure. The formula cannot be calculated based on a blank cell. Choose the error checking tool from the Formulas tab in the Formula Auditing command group. Mac tip. In the Mac version, the error checking tool is located in the Formulas menu. When the window appears, choose Show Calculation Steps, Figure 10. 56. This opens the Evaluate Formula command, which shows the formula already solved, Figure 10. 57a. When examining the formula, you can see the values of 0. 65 for the rate and 750,000 for the principal. Because the PMT function requires you to input n, or the number of payment periods, you would also expect to see 10 in the formula. But there is a 0 instead of a 10 in the n variable location in the formula. Thus, you can see where the problem in the formula is, so you can fix it. If you then close the Evaluate Formula window, you are taken back to the error checking tool from where you can choose Edit in Formula bar. When selected, the cells used in the formula are highlighted. At this point, you should see that the formula uses cell C1, not C2 as was intended. Revise the formula to replace C1 with C2, Figure 10. 57b and run the error checking tool again. Now the worksheet doesn't have any errors, Figure 10. 58c, error checking box opens to show calculation steps button highlighted. In the spreadsheet, cell F4 displays NUM instead of a number as in other cells in that column. Figure 10. 56 the formula cannot calculate an answer because of an error on the worksheet. The error checking tool is similar to the Evaluate Formula tool, except that it checks the whole worksheet at once. Used with permission from Microsoft. A Evaluate Formula box displays reference, Sheet 2. F$4 and Evaluation, PMT 0, 55, 075000000, NUM displays in cell. B. Formula bar displays equals PMTE4 $C$2 $C$400. NUM displays in cell C12 with small green triangle at the top left. Figure 10. 57a Show calculation steps will show you where the error is located. B. You can adjust the formula to address the error on the spreadsheet. Used with permission from Microsoft. In the spreadsheet, cell F4 is selected and lists $99,500. 83 inside. Microsoft Excel box displays the error check is complete for the entire sheet. Figure 10. 58 running error check again indicates that the spreadsheet is now error-free. Used with permission from Microsoft. Spotlight on ethics. The tick and tie method. All businesses should have multiple ways of checking and auditing their financial statements. Often this is referred to as checks and balances. One example for banking purposes would be to require 2 signatures on all checks that are written on the account. That then ensures that 2 different people have approved the check. The concept of auditing in accounting is checking and double-checking that the financial statements are accurate and follow the appropriate accounting standards. This not only protects the company from the consequences of errors, but it can also ensure that the company employees are not committing any wrongdoing. One method to accomplish this is the tick and tie internal auditing method, which involves verifying the numbers on one financial statement with those on another. Managers can use this method internally to monitor transactions for irregularities, payments to unknown vendors, for example, or verify that company financial statements balance before the external auditors do a yearly review. It is better to monitor constantly and consistently than to wait for the external auditor to find the errors. Also, by having a regular internal audit of the finances of the company, you can create a culture that expects honesty and integrity. If you happen to find a deliberate error by an employee, you can address it quickly. By using the tools available in Excel, you can set up an internal audit system to use regularly, thus creating the culture in the organization and identifying misconduct quickly. Learning objectives. By the end of this section, you will be able to create custom formats for worksheet or table for appearance. Create custom formats for a worksheet or table for content. Copy formatting from one range of data to a new range of data. It is important for organizations to use uniform branding and style, which can appear anywhere, from emails to invoice templates to Excel files. Having a uniform style within an organization adds a level of professionalism and consistency to the business, and these may be tied to the company's intellectual property and similar protections. Many organizations provide guidelines or manuals for all files produced to ensure that all employees can easily follow the same style or use the same templates. Microsoft Excel offers many prepackaged themes and styles that can be easily applied to tables and spreadsheets, but it is also possible to create your own custom format. This can be ideal for businesses that want their products to look a certain way and contain specific branding. Custom formats for appearance. The tables and datasets you've been working with were finished versions, with color, font, table size, and background set. Here you'll create these tables step by step with themes and other style elements, using existing themes. To make formatting easy to use and high quality, Excel offers themes. Applying a theme can quickly change the color scheme, fonts, and size of a table or graph. For example, you could easily change the formatting of a table without manually readjusting everything. If your objective is to save time when changing the overall formatting, choose a default theme and all the formatting will be handled automatically. To access themes, go to the Page Layout tab and select the themes icon, Figure 10. 59A, then choose any of the available themes. WISP is shown in Figure 1061. All of the formatted tables and graphs in that particular workbook will be changed. If you have a simple worksheet with no specific formatting such as colors, font style, and the like, when you choose a theme, nothing will change. However, if you have a worksheet with formatted headings and charts, you will notice changes when you select a theme. The color combo box lets users further modify the theme by selecting a different color palette, Figure 10. 59B. For additional changes, the Home tab has a combo box called Cell Styles that lets users select other font sizes or background colors, as shown in Figure 10. 60. Depending on your selection in the Colors menu in the Themes command group Page Layout tab, the options in the Styles menu will change. For instance, use blue from the palette, and in the Styles combo box, select Heading 3 and Accent 5 40%. If an orange color palette from the Color menu was chosen, the Styles options would be orange tones. A Themes button is selected and opens to Options for Office, various color combinations displayed, Browse for themes, save current theme. B Office pane displays color options for selection and customize colors. Figure 10. 59A Themes are useful if your company has a custom theme to apply for all charts. B Color schemes can be customized to meet your needs. Used with permission from Microsoft. Cell Styles button opens to options, good, bad, and neutral data and model, titles and headings, themed cell styles, and number format. Selections available for new cell style and merge styles. Figure 10. 60 You can use the built-in themes to automatically format heading and numbers. Used with permission from Microsoft. A spreadsheet is shown with a theme applied. Row 1 is highlighted light green with numbers bolded and a new font is used. Figure 10. 61 Applying a theme is easier than formatting each section of the table individually. Used with permission from Microsoft. Creating custom themes. Often companies will have a color scheme for all communications and materials within and outside of the company. The palette is usually linked to the company logo and is an essential part of creating a unified and professional appearance for marketing purposes and legal usage. If a company has a specific theme, it can be saved and used by all employees. The saved theme file can be shared company-wide to ensure consistency. Moreover, the saved theme can be used across all Microsoft products. There are two ways to create a custom theme. First, users can create the theme from scratch. This means you define the font, color, and other elements of the theme. Second, and perhaps easier, is to start with an existing theme that is close to the desired theme. You can then make the needed adjustments such as changing the font or modifying heading colors slightly. First, format your table using the desired settings, and then choose Save Current Theme at the bottom of the Themes menu to save the theme as a file that can be used in other Microsoft products and/or shared with others. Link to Learning. Go to Microsoft's theme repository and look for Excel themes. Think about how they might be used in a business. Look for themes that might be appropriate for an accounting department or a human resources department. Other formatting tools. Another time-saving strategy is using the Format as Table tool. On the Home tab, select the Format as Table combo box to see many options for formatting tables, Figure 10.62. The background color, heading font, and borders can be changed. Additionally, column widths will change automatically to fit the text. This feature also automatically adds filters to the columns, which can help with organizing the data in a table, Figure 10.63. However, using the Format as Table feature does not format cells according to their content, such as currency. Format as Table button opens to options for light, medium, and dark. At the end of the list, there are options for new table style and new pivot table style. Figure 10.62. The Format as Table tool is a simple way to add full formatting to basic tables. When you format the selection as a table, there are several color options and themes to choose from. Used with permission from Microsoft. A spreadsheet with information is displayed. Figure 10.63. You get a filter option after the selection is formatted as a table. Used with permission from Microsoft. Adding images to the background. Beyond formatting cell content, you can also add an image to a table's background. The background is a canvas that is displayed behind the cell contents of a worksheet. It could be useful to add a logo or a topic-related image to the background of a table, especially for an internal or client-facing presentation. Often, this feature is used to indicate that documents are not finalized but in a draft stage. To add an image in the background, first select the table, then go to the Page Layout tab and select Background. You will then be prompted to select an existing file, or you can search online for an image. An image of the word confidential has been added in Figure 10.64 to show that this report should be kept confidential and not shared. You may insert an existing file or search the internet for a picture. Diagonally across the spreadsheet, the word confidential is shown 4 times behind the data in capital red font. Figure 10.64. The background change tool is useful for design purposes or for company branding. Used with permission from Microsoft. Custom formats for content. Custom formats for content allow users to design a format for data contained in cells. For example, you can use custom formatting to set a format type for how your purchase order numbers are input into your company's system, or to change how dates are displayed. This feature is different from merely changing a cell's format, such as the decimal points displayed or how months are abbreviated. Instead, the custom format can be saved as a format that is then widely applied to worksheets. You can create a format from scratch, but it is easier to use one of the built-in formats and adjust if necessary. You can customize most aspects of the formatting, from spacing to displayed decimals to font color. Shortening large numbers. Sometimes, the appearance of many repeated large numbers in a spreadsheet can be overwhelming. Other times, you may simply want to reduce numbers to estimates. Excel can shorten large numbers so that they are summarized by a letter, such as K for thousands or M for millions. Figure 10.65 shows that the estimated COGS varies depending on the quantity sold and the unit cost. Throughout this spreadsheet, decimals are removed from the numbers. Row 1 is populated with 2-digit numbers in the 2nd, 5th, 6th, 7th, and 8th columns. Figure 10.65. Shortening estimated figures can be useful for presentations and reports, as they will be easier to read than these long numbers. Used with permission from Microsoft. Since these figures are estimations for the coming period, they can be abbreviated to the million by marking with an M. To do this, select the cells on which to perform this process and then right-click and select Format Cells. In the Format Cells dialog box, go to Custom as shown in Figure 10.66. In the Type field, delete the existing text, type 0, M, and then click OK. Using the 0 indicates no decimal points and to use only whole numbers. The M is used to round to the million units. Excel will change the figures in the selected cells to be rounded up to the nearest million, as shown in Figure 10.66. Number tab is selected in a Format Cells pane. Custom is selected from category, sample is $10,850,000 and options are visible for type. Spreadsheet is selected in background. Figure 10.66. There are multiple custom formatting codes, as you can see in the list. Used with permission from Microsoft. Columns E to H in the spreadsheet are shown with numbers listed with 2 digits followed by an M in the second row and lower. Figure 10.67. Choosing to format large numbers to display as millions can make a table more readable. The finished product could now be further formatted for appearance. Used with permission from Microsoft. Common number formats. Some number formats come up frequently, such as addresses, phone numbers, or social security numbers (SSNs). Their formats may be consistent in a specific region, like SSNs in the United States, or they may be similar with variations, like phone numbers with all hyphens, and parentheses or spaces. In Figure 10.68, you can see a table of names and contact information. However, there are some issues with the data. The numbers all look the same. Phone numbers should be separated by parentheses for the area code and a hyphen after the exchange, and SSNs use hyphens around the middle 2 digits. Zip codes should be 5 digits long, but some are showing up as only 4 digits. This is because Excel does not recognize the leading 0. As is, the data in the current table is confusing. Microsoft offers a standard command to format cells in these situations. In the spreadsheet, the numbers listed in columns E, zip code, F, phone, and G, SSN, are entered with no spaces or punctuation, and numbers are missing from the zip code list. Figure 10.68. There are ways to fix the formatting issues in this table without having to manually fix each one. Used with permission from Microsoft. First, select each column separately, right-click each column, select Format Cells, and then select Special. For formatting zip codes, Figure 10.69, select the zip code column values but not the header, and in the Special Format Cell dialog box, select zip code and choose OK. Follow the same steps for formatting phone numbers, Figure 10.70. As you can see in the results shown in Figure 10.71, Excel already has special formats for these number types. Zip code column is selected in Spreadsheet. Number tab in Format Cells panes is selected. Special is selected in category, sample is 7101, zip code is selected in type, and locale is English. Figure 10.69. Microsoft already has preset formatting for many number types, including zip codes. Used with permission from Microsoft. Column F titled Phone is selected, and phone number is selected in the Format Cells window open under the Special category. Figure 10.70. Another preset formatting is for phone numbers. Used with permission from Microsoft. Table displays consistent information for zip code, 5 numbers, and phone numbers, first 3 digits in parentheses and a dash between the third and fourth numbers. Figure 10.71. The finished product can save the consuming process of writing the parentheses or hyphens manually and decreases data entry errors. Used with permission from Microsoft. Link to Learning. The Mail Merge feature of Microsoft Word allows the user to create letters, mailing labels, or envelopes from a list of names and addresses such as a customer list. This can make the process much quicker than formatting each letter or envelope individually. Often lists of customers with contact information such as addresses and emails will be organized in a spreadsheet. Mail Merge connects a Word document to an Excel data table to seamlessly create the documents needed for mailing. Watch this tutorial from Business Insider on Mail Merge to learn the steps. Copy formatting. Copying the format of a given cell is one of the most used commands in Microsoft Office because it is available not only in Excel, but in all other Office applications. The Format Painter command lets a user copy a certain range's formatting and apply it to a new range by selecting the cell with the desired format to be copied, and then selecting the Format Painter icon on the Home tab. Format Painter can be used to transfer the formatting from one cell or a whole table to another cell or table. The Format Painter tool is the paintbrush icon on the Home tab in the Clipboard command group. To use the tool, first select the cell or cells that have the formatting you want to apply to other cells. Figure 10.72 shows the selected cells E1 to G7. Then click on the paintbrush icon on the Home tab. As you do, your cursor will change to a paintbrush. With that paintbrush, select the range of cells to which you want to apply the formatting. In this example, those cells are A1 to C7. The unformatted table will then be formatted in the same manner as the formatted table. The result is apparent in Figure 10.73. The only step left is adjusting the columns by clicking on the border of each column on top. Cells E1 to G7 are selected. Under the Home tab, the paintbrush icon is selected in the Clipboard section on the toolbar. Figure 10.72. The Format Painter tool allows you to copy the formatting from one table and apply it to another. Notice the cursor paintbrush next to it, used with permission from Microsoft. Two tables are visible with similar information and font color, but formatted differently. Column sizes adjust to text in second table. Figure 10.73. Both tables are formatted using the same font, fill color, and number format, used with permission from Microsoft. Mac tip: the Mac version uses cell styles to format cells. There are also other ways to copy formatting. Another way is to use the Paste Special tool. You first select the whole formatted table and press Ctrl+C to copy it, then select your entire unformatted table, Figure 10.74a. Then, on the Home tab, choose Paste Special from the Paste menu and click on Formatting R from the last row as shown in Figure 10.74b. This tool will paste just the formatting from your original selection. It will not paste any of the values or formulas. Figure 10.74c. A table is selected for copying. B. Paste button opens to Paste Special option. C. Formatting has been applied to the previously selected table. Row 1 is blue and bolded. Figure 10.74 Paste Special can be used instead of the Format Painter tool. A. First, copy the table with the formatting you want to apply, then highlight the table where you want to apply the formatting. B. Choose Paste Special. C. The tool applies the formatting only. It does not copy any of the cell contents. You would then adjust your column widths to avoid the error. Used with permission from Microsoft.